In this tutorial, we will explore various matrix operations. These include addition, subtraction, multiplication, and inverse. We will also solve example problems and provide practice questions to solidify the concepts. Matrix addition and subtraction require the matrices to have the same dimensions. In this example, we add corresponding elements from matrices A and B. Let's work through the matrix addition example carefully. We are given two matrices, matrix A, which is 1, 2, 3, 4, and matrix B, which is 5, 6, 7, 8. We want to find A plus B. Step 1, we start by adding the first elements in the first row. In matrix A, the first element is 1, and in matrix B, the first element is 5. Adding these, 1 plus 5, gives 6. Step 2, we move to the second element in the first row. In matrix A, the second element is 2, and in matrix B, it is 6. Adding 2 and 6 gives 8. Step 3, now we move to the second row. The first element in matrix A is 3, and in matrix B, it's 7. Adding 3 and 7 gives 10. Step 4, for the final element in the second row, in matrix A, we have 4, and in matrix B, we have 8. Adding 4 and 8 gives 12. So, the result of A plus B is the matrix 6, 8, 10, 12. This process of adding corresponding elements is fundamental in matrix addition. Now, let's walk through the first practice problem together. Matrix A is 2, 4, 6, 8, and matrix B is 1, 3, 5, 7. Step 1, we start by adding the first elements in the first row. In matrix A, the first element is 2, and in matrix B, the first element is 1. Adding 2 and 1 gives 3. Step 2, for the second element in the first row, matrix A has 4, and matrix B has 3. Adding 4 and 3 gives 7. Step 3, in the second row, the first element in matrix A is 6, and in matrix B, it's 5. Adding 6 and 5 gives 11. Step 4, for the second element in the second row, matrix A has 8, and matrix B has 7. Adding 8 and 7 gives 15. The result of A plus B is the matrix 3, 7, 11, 15. Now, for the second practice problem, matrix A is 0, 5, 9, 1, and matrix B is 4, 3, 2, 6. You can apply the same steps to find the result. Matrix multiplication is a more complex operation. You multiply the elements of each row of the first matrix by the corresponding elements in the columns of the second matrix and sum the results. Let's walk through matrix multiplication step by step. We are given matrix A, 1, 2, 3, 4, and matrix B, 5, 6, 7, 8. We want to compute A multiplied by B. Step 1, we begin by multiplying the first row of matrix A by the first column of matrix B. We multiply 1 by 5, which gives 5, then we multiply 2 by 7, which gives 14. Adding these two results, 5 plus 14, gives 19. This is the first element in the resulting matrix. Step 2, we multiply the first row of matrix A by the second column of matrix B. Multiply 1 by 6 to get 6, and then multiply 2 by 8 to get 16. Adding these gives 6 plus 16, which equals 22. This is the second element in the first row of the result. Step 3, now we move to the second row of matrix A. Multiply 3 by 5 to get 15, then multiply 4 by 7 to get 28. Adding these, 15 plus 28, gives 43. This is the first element in the second row of the result. Step 4, for the final element, multiply the second row of matrix A by the second column of matrix B. Multiply 3 by 6 to get 18, and 4 by 8 to get 32. Adding these gives 18 plus 32, which equals 50. The result of A multiplied by B is the matrix 19, 22, 43, 50. This process, multiplying rows by columns and summing the products, is fundamental to matrix multiplication. Let's work through the first practice problem together. Matrix A is 2, 0, 1, 3, and matrix B is 4, 5, 6, 7. Step 1, multiply the first row of matrix A by the first column of matrix B. Multiply 2 by 4, which gives 8, and 0 by 6, which gives 0. Adding these results gives 8. Step 2, multiply the first row of matrix A by the second column of matrix B. Multiply 2 by 5, which gives 10, and 0 by 7, which gives 0. Adding these results gives 10. Step 3, now for the second row of matrix A. Multiply 1 by 4, which gives 4, and 3 by 6, which gives 18. Adding these results gives 22. Step 4. For the final element, multiply the second row of matrix A by the second column of matrix B. Multiply 1 by 5, which gives 5, and 3 by 7, which gives 21. Adding these gives 26. The result of A multiplied by B is the matrix 8, 10, 22, 26. Now, you can solve the second practice problem on your own. Matrix A is 1, 4, 2, 3, and matrix B is 0, 1, 5, 2. Follow the same steps to find the result. Finding the inverse of a matrix is useful in solving systems of equations. Only square matrices with non-zero determinants have inverses. Let's work through the steps of finding the inverse of a matrix. We are given matrix A, 4, 7, 2, 6. The goal is to find A inverse or A superscript 1. Step 1. Calculate the determinant of matrix A. The determinant is found by multiplying 4 by 6, which equals 24, and subtracting 2 multiplied by 7, which equals 14. 24 minus 14 gives 10, so the determinant of matrix A is 10. Step 2. Now we apply the formula for the inverse of a 2 by 2 matrix. First, swap the elements of the main diagonal. This gives us 6 in the top left and 4 in the bottom right. Then, change the signs of the other two elements. So, the top right element becomes -7, and the bottom left element becomes -2. Step 3. Multiply the entire matrix by 1 over the determinant. Since the determinant is 10, we multiply each element by 1/10. This gives us 1/10 of 6 -7, -2, 4. So, the inverse of matrix A is 1/10 of 6 -7, -2, 4. This process is important for solving systems of equations using matrices. Let's work through the first practice problem together. Matrix A is 3, 8, 4, 6. Step 1. Calculate the determinant. Multiply 3 by 6 to get 18, and subtract 4 multiplied by 8, which is 32. 18 minus 32 gives -14. The determinant is -14. Step 2. Now swap the elements of the main diagonal. We have 6 in the top left and 3 in the bottom right. Then, negate the off-diagonal elements. The top right becomes -8, and the bottom left becomes -4. Step 3. Multiply the entire matrix by 1 over the determinant. The determinant is -14, so we multiply each element by -1 over 14. The result is -1 over 14 times 6 -8, -4, 3. Now, solve the second problem, matrix A is 2, 5, 1, 3, by following these same steps. Let's test your understanding of matrix operations with the following quiz questions. 1. What condition must be met for two matrices to be added together? 2. How does matrix multiplication differ from matrix addition? 3. What is the requirement for a matrix to have an inverse? 4. Explain how you multiply two matrices. 5. What is the inverse of a matrix? Answer these questions to assess your grasp on matrix addition, multiplication, and the process of finding inverses. Here are the answers to the quiz questions. 1. For two matrices to be added, they must have the same dimensions. 2. Matrix multiplication involves multiplying rows by columns, whereas matrix addition is element-wise. 3. A matrix must be square, and its determinant must be non-zero for it to have an inverse. 4. To multiply two matrices, you multiply the rows of the first matrix by the columns of the second matrix and sum the results. 5. The inverse of a matrix is a matrix that, when multiplied by the original matrix, results in the identity matrix. Review these answers to ensure you understand the key concepts in matrix operations.